Now, our first presentation this morning is entitled SCInet, a volunteer's guide to the fastest temporary network in the world. I'd like to introduce Annalicia Duran and Corey Eichelberger, who will be presenting this talk. Annalicia is a network engineer at Internet 2, so be nice to her. She works with me. She has to deal with me. And she's traveled from West Texas to be here. Corey is a network engineer at the Texas Advanced Computing Center and has traveled from Minnesota to join us. It's their first time presenting at NANOG. Annalicia said she's a little bit nervous. So, big smiles. You're going to be great. Welcome, you two.
How will they be going through the slide?
You've got a clicker. Green button.
Do we want to stand?
Standing's probably good.
Okay. Hello, everybody. As Adair said, I'm Annalicia Duran. I'm with Internet 2, and today we're going to be talking about supercomputing and SCInet. So I've been doing SCInet for 3 years. This is the first year that I'm in a lead role for our routing team.
And I'm Corey Eichelberger. I work at the Texas Advanced Computing Center, covering networking and security. I've been working on SCInet since 2017, bouncing through a few different teams, including routing, network security, and I'm currently this year's technical director.
So what is supercomputing? Has anybody been to supercomputing? Has anybody volunteered with SCInet? Supercomputing was established in 1988. Its technical program is held every November, and it's sponsored by the ACM and IEEE. So the goal of supercomputing is to unite researchers, engineers, and scientists to present their latest work, exchange ideas, and learn about the latest advances in HPC. Supercomputing also offers a student program that empowers students in computing and related science and engineering fields. Students are targeted for development, mentorship, and there's a dedicated job fair and direct engagement with SC's technical content. So here's just some quick numbers from last year's supercomputing that was held in Atlanta in 2024 with over 18,000 people attending, almost 500 exhibitors that showcase their products and services, and 37 network research experiments with 200 plus technical sessions, workshops, and birds of a feather sessions. So that's a quick update on what supercomputing is in the conference, but what is SCInet? How does supercomputing provide a network powerful enough to support HPC? SCInet was established in 1991, and it was created to deploy a temporary show floor network that provides connectivity for exhibitors and attendees of the annual conference. SCInet is the infrastructure that supports high throughput traffic, services, and resources for demos and experiments that are hosted by researchers to showcase innovation in network hardware, protocols, and advanced network-intensive applications. SCInet uses connections for a global network of researchers and engineering institutions to provide connectivity for exhibitors and attendees.
So who is SCInet? We've gone over a little bit of the what, but in 2024, we had 200 different volunteers comprising from 8 different countries, 34 states, and 114 different institutions across research and education, private sector, and other different organizations. So all of these folks have to go somewhere. We have 18 specialized technical teams and then some other teams that are more on the soft side of things, which we'll go over a little bit later. Also, we have 32 contributors that are including all the equipment for SCInet. So SCInet itself acts as a giant interop lab where we're able to test out the latest and greatest technologies, make sure that vendors are actually doing interoperational work between each other, and being able to work directly with the vendors themselves as they send folks from the institutions and engineering teams to actually work on bugs as we find them. So among those 32 contributors, between hardware and software, we had about $47 million was the mark of what was donated last year. Keeping in mind that is not the actual MSRP, that is the actual vendor cost, which is how we calculated all of that. MSRP, take your standard markup. I'm sure you can figure out that number by yourself. So continuing on with who is SCInet, going over those technical teams. We have technical teams everywhere from architecture and interconnect to make sure that someone is actively guiding the design through the entire process, to your standard, network security, your routing team, WAN team, and also a dedicated fiber team to actually get all the booth fiber down. These are just a few of these. We also have a wireless and edge team that do all of the wireless and edge networking. But one of the things that most people don't really think of when they think of SCInet is the non-technical side of things. We have a dedicated team specifically for contributor relations and logistics that are actually helping us wrangle all those vendors as we put together all those bombs. Across those 32 contributors and close to $50 million worth of equipment, someone has to actually figure out when it's all coming in, where it's being shipped to, make sure it all comes in on time, and making sure that we have everything that we need for actually setting things up in the actual physical spaces that we have there. On top of that, we also do have more of an executive team that's kind of overseeing that, similar to what you would have in any larger organization, with finance and other roles assigned underneath it there. So lots of opportunities for folks to participate in SCInet, grow in their own careers, and go from being a standard team member to a team lead. And if they wanted to explore a different team, people are free to move between those, which is one of the great things about SCInet. So on the slides there, you kind of get a view of just who all those people are. Those are the folks that were able to actually show up on site. We have been doing more and more hybrid approach for SCInet just since COVID, with institutional funding and other issues continually popping up. We have to find a way to meet our volunteers where they are, and sometimes that means that they're not able to get travel funding to spend a month in a different city, or they might fly in for a week and then have to do the rest as virtual. But that kind of gives you a view of who's up there. So this gets to our tagline for SCInet. SCInet, what we like to tell people is 1 year to design, 1 month to build, 1 week to operate, and we tear it all down in 1 day. So getting into that, the 1 year design portion, I will put a small asterisk on that, just given that the 1 year design is really where the core focus of the efforts begin, with team leads and regular team members. As you can imagine, going to different conference centers around the US, there's a lot of logistical issues, and some of these things actually start taking place multiple years in advance, especially when you're trying to get fiber and other things and all the various contracts that you need to with unions and everyone else. But I'll stop sidetracking now. So for your average team leads and most of SCInet, planning begins around the January timeframe. We put out an initial call for ideas, anything that team leads might want to do this year, what are the new technologies, and asking vendors, hey, what do you want to show off in this giant interop lab that we have on this convention center floor? So around February timeframe, we start putting out a call for volunteer participation for those 18 teams. And then, after that, we're off to the races, regular meeting, basically every single week between team leads and the executive team, trying to figure out where everything is, what's available for hardware, what are the issues that are going to come up this year, whether that be technical or more on the personnel side. This year especially, we're seeing a number of funding issues, just given that we're mostly within the public sector space, and we have a lot of folks coming from various research and education institutions where budgets are maybe a little tighter, and various travel bans are in place at this point. So a lot of fun things to work out, not always technical, but we work through it. So the focus before the show is to build and test the network. Once we have that straw man, we start working through the routing team and others. We put things inside of a lab. We have a lab, actually. We have 2 labs actually. One is a GNS3 based lab in Poland to serve the bulk of our European contingent, and also some of our others. And then we have a lab that's hosted in Austin at my home institution that's focused more on the automation side of things, and also some different things as needed.
So after the year of planning, we get to the 1 month to build it. The first stage is staging, and that takes place about a month before the conference. Staging will take place at whatever venue is going to be for that year. So all of the teams will meet to receive inventory and unpack it, from devices to racks, power systems, and then we focus on racking, stacking, powering it on, configuring it, patching it, and testing it while we can. The setup process, that takes place a week leading up to the show. Teams will physically move and relocate all of the devices, all of the network components from the staging area to their designated spots throughout the exhibit floor. This includes moving and positioning racks in what we call the NOC stage, reestablishing power, and continue to monitor and test during the network turnup. As the week progresses, researchers begin their booth setups, aiming to be fully operational by Saturday at noon. The conference session starts Sunday morning at 8 a.m., and the grand opening of the exhibit floor is on Monday evening during a gala event.
So once we've built the thing, we actually have to operate it for a full week. And some of that has come with its own set of challenges after COVID and everything else has come along. The conference itself has actually changed quite a bit. What used to be kind of a plucky upstart network where we were all testing things and we could go ahead and take down a peering or a core router during the middle of the day and say, oh, it's fine, those people over in those workshops over there, they just might lose connectivity for a little bit and we'll try and route around it. Streaming has become a major thing, as you've seen for probably the rest of your conferences that you might go to, this one included. So we have to maintain things fully operational, not just for the conference center floor, but also supporting things for all the attendees, and then streaming at the conference for all the virtual attendees, at the highest level of reliability that we would see at our home institutions. So with that, after people have spent 3.5 weeks building the network, they then get to sit in the NOC and we get to monitor and troubleshoot issues as they come up. A lot of interesting things going on, but the main thing there is, just evaluating, making sure that we have the resiliency that we need and everything else. So this kind of gives a brief overview. In the upper left-hand corner, you'll actually see a picture of the NOC stage itself. Looks like that might have gotten cropped off a little bit. There should be 8 racks on the NOC stage there, but it also kind of gives you a view of the equipment that we might have on the NOC stage. Again, multi-vendor interop is a big thing for us, so we make sure to try and have representation from all the major vendors on all the teams as much as is possible, right? Demo pools and other things tend to be a bit of an issue, but we make do with what we have. So the upper right-hand corner is actually the SC Theater. So what we do there is we have a mix of both SCInet folks and folks from our network research exhibitions, which we'll cover a little bit later, actively giving tech talks and educational talks on what they've done over the last year and trying to help focus that on training up the next set of network engineers that are coming through, but also providing a better view for the rest of the conference as to what SCInet is. That's been an important process for us, and that's been something that's really come into prominence over the last couple of years. And finally, we have dashboards and everything else that are posted on the NOC and the distributed, we call them DNOCs, distributed NOCs that actually have all the edge networking. Lots of fun things there from our monitoring and measurement team, different statistics of what's going on the show floor. As always, people love all the pretty graphs, and we get to do a lot of fun visualizations each year. The most popular perennial favorite is a dashboard where we actually aggregate all of the DNS queries and traffic to various dating apps and show folks what dating apps are active on the show floor that year. Much to the ire of some of the executive committee at times, just because of some of the flack they get. But, it's always fun seeing everyone for the 24 hours that we get to keep it up, taking photos with their cell phones and, looking and seeing what's going on inside of an academic conference of 18,000 people. Oh. And finally, once we've all gone through that, everyone's super tired, we have the most dangerous portion of the event, which is teardown. So the show floor, much like any exhibit trade show floor, it closes down at 3 o'clock on Thursday of that week. After that, we're able to take down most of our peerings. We do have to keep up a small portion of the network to have various conference entities, including registration, but also some of the workshops that are going on. But the bulk, probably about 80 to 90% of SCInet is actually torn down at this time. So starting at 3 p.m., we shut everything down, take down all those peerings, power off all the equipment, make sure configs are scrubbed, and then we literally forklift those racks back off of the stage and start unracking and working on the process of getting things into boxes. This is, again, probably the most dangerous portion of SCInet, just given that everyone's tired. We've all been working together for 3.5 weeks. Late nights, bad eating, bad drinking, everything else. But we all come together to make it work, and we usually are able to get things done by 5 p.m. on Friday. Again, $47 million worth of equipment. That's kind of a big deal. It's mass chaos, but we make it work every year. Yeah, and then, all of our main infrastructure is then shipped out, and we're able to, have a good time that night.
So why SCInet? Why do we put ourselves through this all year long? While the conference itself delivers a strong technical program, SCInet's ability to offer an environment that is designed to empower research is in large part of our goal. SCInet provides a rare and vital platform to test experiments and deliver compelling demonstrations in a controlled environment that overcomes limitations that network researchers might find in the real world. Unlike typical conferences that may be limited by the venue's environment, SCInet collaborates with various contributors to provide an extended range of access through the event. Beyond standard internet connections, researchers can request specialized services for their booths months in advance, which allows us to evaluate their request and whether or not it's achievable. Last year, SCInet acquired cutting-edge 400 gig and 800 gig capable routers and switches, and through collaboration with Internet2 and SCInet, SCInet established high-speed, secure connections to the research and education network via BGP peerings. This helped bypass limitations of commercial internet, offering researchers low latency, high bandwidth access to global institutions, organizations, and cloud connections. So this is not your typical Netflix streaming connectivity. Last year, we had 37 accepted experiments and demos. I'm going to talk about one of them briefly that was submitted by NICT for their data transfer experiment. NICT requested 10 100 gig lines that were used to connect their servers in Tokyo to their booth in Atlanta. And they used that to perform a high-speed transfer experiment using the high-speed file transfer tool MFCFTP. Their target speed was 800 gigs. We did run into some issues with that experiment, so the result was 466 gigs, but I think that's still pretty good from Atlanta to Tokyo.
Yeah, and some more examples, and one of these is actually another NICT example. They're one of our big contributors there. They actually were doing, so NICT is based in Japan, so these are all trans-Pacific lines, right? They were doing on the show floor video processing of uncompressed 8K video using an SRv6 based service under the underlay. these things, along with your standard data transfer things, NASA Goddard has been working with us for a number of years on doing 400 gig disk-to-disk WAN file transfers. We have a number of other folks within the high energy physics, astronomy, biophysics, and other realms that are working on different data transfer tools, different protocols, and also working with a number of different cool things like programmable data planes in P4. So we'll actually, there are times where we'll bring those test beds in, and I think last year we broke one of the test beds, put it directly into SCInet, and we're just another leg in there of doing all these things. So a lot of moving parts, a lot of different test beds around the world. These NREs, we literally loop, coordinate fiber for these experiments that literally cross the world, US to Asia, to Europe, and then back around. They'll test out different protocols at higher latency, and given the bandwidth and everything else, they're actually able to find different issues with hardware and protocols and everything else that they wouldn't be able to get with their average home institution, just because being able to coordinate these multiple 400 gig circuits around the world, that kind of takes some effort, takes some time, takes a lot of donations from various fiber vendors, and so we're able to do some really cool things there.
So this graph just kind of gives a summary of how we connected NICT's 10 connections from Atlanta to Tokyo. And keep in mind, this is just one of 37 experiments. Internet 2 was involved in helping to connect 3 of those connections. So you can see in the green where Internet 2's connections began at our global exchange point, and then we hand off to Canary, and then from there to Géant, and then all the way up to Tokyo.
So let's get into some special projects that maybe were not part of these NRE demonstrations, were actually internal to SCInet themselves. So over my years on routing and other things, we've done a number of really cool things. One of the more recent things is that we had a full multi-vendor EVPN VXLAN fabric across 4 different vendors and 5 different platforms, providing connectivity for all the booths on the show floor. That's something that we have been working on since about 2018. We first put that into production in 2021 and continued that until 2023. A lot of great things working with vendors on getting multi-vendor EVPN VXLAN working, especially in the early days, since there are different portions of the spec where you can do an either or. So we were able to direct a few vendors to be able to align with others on that. Really cool things there. Also got some good configs and other things that folks can take home to their home institution while also contributing back. So one of the more recent efforts, especially with various government mandates to go V6 only within various federal agencies, we've been doing a lot of V6 only work. 2023 was the big one where we started doing IPv6 only client networks. We run that as a separate SSID from the regular SSID, much like you have at NANOG here. Testing out NAT64, DNS64 infrastructure, and also just finding all those weird little bugs inside of clients where Microsoft Teams and others have just coded in v4 literals. Well, that obviously doesn't work with DNS64 and other things, so we then get to work with the folks, different vendors, and try and help us work together toward, actually going toward a v6 only world. We'll get there eventually, yeah, that's about right. So, Firewall Sandbox, that was actually one of my big things that I worked on last year with the network security team, was trying to have, so for most of the firewall vendors, their main focus on being able to tune for performance and everything else is on your standard iMix traffic that you probably see most in the service provider world. Within R&E, especially when we're looking at doing data transfer and other things, within the open science world, no firewalls, we just let the packets roam, blast those packets as fast as you can, but especially with CUI, HIPAA, and various other different data classifications that we're having to deal with, firewalls are coming more and more into play for science DMZ architectures. So what we did is we had a firewall sandbox where we had tried to gather 400 gig firewalls from all the major vendors, and then had a standard data transfer test set based upon what we see in real life. And, we were able to sit there and work with the vendors over the course of 4 days of, finding different tuning parameters for firewalls to be able to, help out with some of those elephant flows, but also being able to tune for, grid FTP under Globus is one of the big ones for us, but also Ruccio, BBCP, and a few other file transfer protocols that, most of the vendors hadn't even heard of. Being able to find ways to tune the firewalls for optimal performance for scientific data transfer. So, lots of interesting things there. Last year was the first time we had an on-prem HPC cluster, which is a bit surprising for a supercomputing conference, but we're trying to get that program up and running. Running into hardware issues there just because getting things from server vendors is a little different than network vendors. But that provides great training for the folks that are on the show floor to, even if they aren't a sysadmin in their day jobs, they're more toward the network engineering side, but they work in an HPC center, giving them exposure to, here's how we build an HPC cluster, here's how you deal with the interconnect, here's what Slurm is, here's how job schedulers work, all of that, so they can take that back to their home institution and be able to integrate that and be able to more effectively work within their home institution. So that's kind of a neat process that we're working on. We've also been doing a lot of early 800 gig interop testing. We had our first 800 gig boxes for SC23. We were able to get 2 devices to link up at 800 gig with some pre-spec gear based on engineering samples. Disappointingly, it kind of just worked. So we didn't have a whole lot to go on there, but we're continuing to do more and more 800 gig testing. We're doing some more this year. So.
As you can imagine, there are some challenges that come with volunteering for SCInet and trying to put a network together for the conference. One of those is it's a fully volunteered team, 200 plus volunteers. As my first year as lead for the routing team, our team alone has 22 plus members. So trying to coordinate team discussions, lab time, training with participants from all over the world in different time zones. That alone is very challenging. Also, as leads, we have to meet with each team member and kind of gauge what their knowledge and capabilities are. Some members have been network engineers for 15, 20 years. Some maybe 3 to 5. Some may have exposure to research and education. Some may only work at a small campus and don't have experience with the same technologies, but that's kind of the point of SCInet, is to give our members exposure to services that they've never worked with before, and they can take that back to their home institutions.
Yeah. So one of the other challenges, and I alluded to this a little bit earlier, is almost all the hardware used by SCInet is donated by contributors. That $47 million number that we had before, that it does include some software licenses and other things, but again, that is the actual vendor cost of the hardware and not the MSRP that's being used for those contributions. So as you can imagine, that's a lot of hardware that's going onto the show floor, tight timelines, we already went over. Our typical deadline is all the hardware has to be at the staging warehouse about a week before staging. Anyone who's worked with demo pools in the past knows that some of those timelines with those demo pools, they're a little bit looser than you would maybe like sometimes. So thankfully we have a great set of vendors that we've worked with and folks that have been doing this for years that really have begun to understand, kind of where we're at on all of that. But we still have issues with, institution X didn't get this back to the demo pool, so you don't get your shiny new toy until 2 weeks late. We've had gear ending up there as late as staging, which is, we have a week to unpack it, configure it, find all the various bugs in it, and then make it work. All of this is a very tight timeline where we're thankful for all the vendors that contribute to us and, great teams, and we always pull it off, but, that's always a challenge, and that can be, it leads for some scary nights at times when, you're sending emails at 10 o'clock at night trying to figure out where this chassis is somewhere inside the US and whether it can get to you within the next 2 days before you have to leave for your break in between staging and setup and show.
Another challenge is during show, sometimes we don't even get to test services until researchers start setting up their booths. So there may be bugs that we don't know about until the week of the show. So we'll still be in the NOC area working on trouble tickets that are put in either through the help desk or researchers showing up at our door knocking that their service is not working to their booth. Last year was kind of a rigorous year. I was part of a team that worked from 8 in the morning till 11 o'clock at night, almost every day of the show for NICT, because we were having issues getting their services going. So that's very challenging when you're working late nights and you may not even get to enjoy the show until the last day. So that's very challenging.
And to put a finer point on that, you were there until 5 a.m. the one night working
Yes.
on a bug. Do you want to go over them at all? Or?
Yeah, so we were having, it appeared to be issues with a couple of booths, their VLANs intercrossing each other and shouldn't have been. So traffic wasn't going where it needed to go for each of those booths. There were some other issues that we ran into as well, that we had to work together with the WAN team and do direct testing off of the routers. Like, where is this traffic going and why is it not ending up in Tokyo where it should be? I went to the NICT booth with maybe 2 or 3 other people during the day, multiple days, and worked with them to see what they were doing to troubleshoot and where traffic was dropping. But we really wanted to get the services that we were trying to deliver to work up until the last day of the show, when we decided to just pseudo wire everything, and everything started working.
So into some of the fun facts. We brought in 8.71 terabits of wide area network connectivity into the Atlanta Convention Center last year. We did have some additional connectivity for the various loops and everything, but we don't typically count that in our press release because that's a little bit harder to quantify and visualize for most folks. We also had our Edge team do a full deployment of Wi-Fi 6E with V6 dual stack to all clients, and then, of course, the V6 only test SSID. We're getting more and more folks on that every year. We've been trying to find ways to encourage folks by giving out things like sparkly conference lanyards and little stickers and everything of, I tried V6 and I didn't die this time. And to kind of put a finer point on that, when we're talking wireless at this conference, it's 18,000 attendees, 450 access points. That's a pretty good spread. The Edge team goes off and does their things, and I've been on routing for a long time and had to, we interop with them and we provide, all the routing and everything else for them. But they're just constantly moving day after day, troubleshooting down access points, everything else. So some crazy things going on there. Also, we had 18 400 gig connections. We didn't have any 800 gig WAN connections last year. We had 800 gig within our Science connector, but we didn't have anything on the WAN side. We'll hopefully have some of that later this year.
We also had 1 megawatt an hour of energy for every 18.5 hours. We had 12.7 plus miles of fiber optic cable installed, 3,500 fiber patches, and 500 help desk tickets. So imagine working 500 tickets during the show.
Okay, on to some of the fun stuff. So we kind of went over some of the network research experiments that we were talking about earlier, and some of those things where we're looping connectivity all around the world. You'll notice that this graph does not add up to the 8T. We did end up pushing, since there is some double counting given how the ring was done, but we did actually hit 10 terabits of bandwidth utilization last year. Again, there is some double counting in there, so the more realistic number is probably somewhere in the 6 or 7 range. But this is one of the things that we love to do every year with all of our network research experiments. We pull everyone together, we do all this, and then toward the end of the show floor, when we're not so worried about everything, we do a blow the doors off event, which is in that graph there. Lots of cool things there. Thankfully, we haven't seen any issues with router stability or anything else, but this does really help all the various NRE experiments see what it takes to actually fill that pipe, and also see what the hardware limitations are on their side for actually generating that traffic. This isn't all just packet gen off of a Mellanox NIC. A lot of this is actually disk-to-disk file transfer or at least memory to memory. So being able to find things with the latest CPUs and everything else, this provides a nice test bed for everyone. And it provides a nice showy graph for us to be able to put up there. So what are we doing this year? We've mostly covered things that we're doing at we did at SC24. One of the big things that we're doing this year, especially with our NRE participants, is we're doing an 800 gig interop test ring on the show floor. We've done 800 gig connectivity, mostly internal, but we haven't actually been handing it off to edge customers yet. The goal for this year is we're going to have those various NRE experiments have actual access to 800 gig to their switches that they bring to the show floor, but also doing 800 gig WAN connectivity from St. Louis to Chicago and other portions of various networks, thanks to folks like Internet2 and Department of Energy Sciences Network and our vendors. It's actually looking like we will have full 800 gig WAN connectivity and be able to do end-to-end 800 gig between various POPs in the US and the actual show floor, which is a pretty big deal given where vendor roadmaps and everything have been and the constant lag there.
And we're also working on a separate network for NRE connections. So before last year, to my knowledge, you can correct me, Corey, NREs shared the network with the conference network, the show floor. This created a hindrance on the experiments that required high throughput to conduct demos and experiments. Last year, SCInet began the endeavor of separating the networks so that NREs had their own dedicated routers and switches, and then you had the conference floor where booths maybe only needed a 10 gig connection. So we started that endeavor last year. Some resources were still shared, but this year we hope to keep it completely separated.
Yeah. And another big project we have this year is, for years we've had our own internal iNext intranet for our source of truth and also for generating patches and everything else within the conference. We are finally joining 2018, 2019, and we'll be moving to Autobot, so that's a big lift for us. We had a lot of custom logic that was written into that intranet over the years, so a lot of also technical debt that is incurred there, right? As anyone who's worked with the old school intranets that were written in the mid-aughts as ours was. So finally making a big move to Autobot. Our DevOps team and our automation team are making big strides there, and that'll be a pretty exciting thing to see.
And we've also added an automation team. In years before, automation was just part of routing. We would dedicate maybe 1 or 2 members to working on automation. But this year, we're really focused on automating configuration of devices using NSO.
So those are links there in case you're interested in joining. While the focus of supercomputing is those who are within HPC and supercomputing, we also have a lot of folks from campuses, different service providers around the US. If you're interested in doing this, next year it's in Chicago. It's getting kind of late to sign up for this year, but if you're interested and you can make it to St. Louis, let us know. I tried to put some links up there on how you can participate. Also, feel free to, just hit us up in the hallway and we can try and see what we can do there. But next year is in Chicago, which is a pretty big destination for a lot of folks. I know there's probably a decent Midwest contingent here that, that might be maybe not a short drive, but not too bad. 18 teams, even if you do mostly fiber and other things and you wanted to try your hand at routing, network security, or other things, the bulk of what SCInet is really about providing not just that interop lab, but also training and allowing you to dip your toes into things that you might want to learn about. So,
even if you want to just attend the conference, Supercomputing, you can still make that this year. That'll be in November, and you can come by and see our NOC stage and see all of the equipment that we configured, and we even offer tours, don't we?
Yes.
You can sign up for a tour of the NOC stage and attend any of the SCInet theater presentations. So that comes to our conclusion. Does anybody have any questions?
Old gray-beard, I yield. Call out Brandon too. Yo, Brandon, where are you? Brandon Ross, stand up. Okay, there's at least 3 of us here, 2 of us at the microphone. I'm Rob, this is Alex, We were 3 decades ago, 4 orders of magnitude less bandwidth and 6 orders of magnitude less actual traffic. We were on the SCInet team for interop.
Oh.
And I have a question for you, and it might be, why don't you go first?
Okay, I'm Alex. If you get a look at it, I'm wearing the 1995 SCInet shirt. Is there anyone who is actually keeping track of the evolution of SCInet? When you were saying you were doing 8 by 100 gig, in 95 we did 8 by OC3 for Hippie.
There actually is. So Annalicia is wearing the shirt this year. SC23 was 35 years of the SC conference, and we had a SC history group, not only on the conference side, but also on the SCInet side. You probably remember him from back in 95, Tom Hutton. Yep, Tom Hutton was the one who put together a lot of that and actually put together a lot of documentation for those things. We do also have kind of a communications group that not only does outward-facing PR, but also tries to find things, documenting photos and also gathering technical documentation from all the folks on all these things. Because yes, a lot of this is lost in the weeds. Just from the brief time that I've been in relative to 1995. I can't quite remember all the things that I've done, so that's very cool. Well, we should talk in the hallway about that. That sounds cool.
Thank you.
So my question is a some things never change question. How are you handling the interface with, division of labor between, and avoiding of misunderstandings with venue staff and unions?
Specific to venue staff?
Venue staff, unions, everything from, hey, you can't move that here because it requires a hand truck, to, oh, sure, you have an OSHA 10 card and a forklift card, but you can't do that, to, but you guys are rated to go up in the bucket, but you don't know how to splice fiber. How do you manage to get good working together with venue staff and good division of labor that plays to everyone's strengths?
You've done networking in conference centers, haven't you? Yeah, that's actually a really great question. So one of the teams that we have on there is, in particular, the logistics team, but also the executive team that handles a lot of that. So within conference centers, the major one that the SC conference works with is called Freeman. They do a lot of major conferences around the US. They're kind of our go-between for a lot of those things, and the logistics team and then various folks within the executive team kind of try and coordinate things, everything from, the NOC being built to, hey, in particular, depending upon what city you're in that year, you might have the Freeman union, but also the local unions for electrical and everything else, right? So it's not a simple answer, as I'm sure you're aware. But we do have folks that are dedicated to that, specifically like on the logistics side and also the executive side that are working through contracts, are actively in communication with Freeman and others. And Freeman is really our main point of contact for a lot of that. Some years we do have some direct communications with the actual unions themselves, depending upon what's needing to be done, specifically, depending upon what unions are in that building and everything. But a lot of that really goes through mostly our logistics and executive team. Very cool. It sounds like the layer 8 and layer 9 stuff has evolved just as much as the layer 1. We got to let the routing folks route. Those of us who, age out of some of that technical stuff can sit in those meetings. Yeah, we go off and do business stuff and risk governance and all that stuff. Thank you.
Thank you.
Okay, thanks for the presentation. So Prabhakar works for Sienna, representing vendor. So I have lots of questions, but I'll just ask two in the interest of time. When you do this initial vendor selection, do you publish requirements, like what type of platform, what type of features that you will be requiring? That's one. And at the end of the show, do you publish any sort of interop report, which is publicly available?
Okay, so there's a few parts there, and We do actually work with Ciena on a number of things, both on the WAN and the routing side, and we're currently working with them right now. It's a good question. We do have, based upon the architecture strawman that we try and put together earlier in the year, we have kind of a lofty set of goals of what we think the architecture should look like, what technologies we're pursuing, and everything else. And we do try and have those within the vendor engagement conversations. But I will say that, at least when I was a team lead, one of the first things that I asked during that initial vendor conversation is, what does vendor X, what does Ciena, what does Arista, Juniper, Cisco want to show off this year? And then we try and take those ideas in and see where they can work within the architecture. But yes, we do have a set of requirements just based upon where we see technologies going, but also what we have the resources for. As much as we would love to do something crazy like SRv6 all the way down to the boost, that's not always, logistically possible given team members and other cycles, and also the platforms that are available to us. So, short answer, it's a little complicated, but we do try and do our best to, let folks know of those requirements up front, but also take feedback on what's available within platforms and where the vendors themselves see technologies going, because most of the folks that we're working with, they're receiving requirements from their own customers on company X is doing this cool thing over here, we're implementing this feature in the code set by September, October, would you be interested in doing this? I'm sorry, I might have rambled a little bit there.
That's good, thank you. The
okay.
interop report, will there be any report at the end that these are the vendors interoperated and it was working fine, things like that?
Is there a report at the end?
So reports get a little bit complicated, just given that by the end of the show, we're all pretty tired. We do try and give things back to the vendors, especially when it comes to, if we had any bugs or any major accomplishments. And it varies depending upon the vendor. Some of them are more keen on, helping us out with getting a press release out, and we're more than happy to work with them. And then others are, they might be happy with that, but that's not necessarily the focus for them. So it varies, but we are super open to putting out press releases and other things. I know we put out a number of them with Ciena over the years, especially as we had, some of those early 400 gig WAN links and other things. So yeah, as most things.
I'll add really quickly is whatever vendors we have that provide equipment, they usually try to send 1 or 2 participants to help with the equipment and give their expertise, so they will know what the limitations were of their equipment during the time.
Thank you.
Well, that's our time, folks. Thank you so much.
Thank you.